Yes, we start. So we just quickly recall what we have seen so far. So first we have started with the formation of partial differential equation by eliminating arbitrary constants, and then we have seen formation of PDE by eliminating arbitrary functions, and then we have solved Lagrange's linear equations, right? Yes. And then we have solved homogeneous second and higher order partial differential equation. So we have solved type 1 to type 6, and then we have solved Char-Pitts method, right? So now in this video we are going to see canonical forms, right? Actually this is not very important, but this is in syllabus, right? It is in the syllabus, so I have to cover, so that's why I am doing it, right? So we are going to study canonical forms today, and then we have only left with Eat equation and Laplace equation, that's it, right? So if I finish canonical forms by today or maximum by tomorrow, and then Eat equation, wave equation, maximum 3 to 4 classes, then syllabus will be completed, right? Yes. So first we are going to discuss what is meant by canonical forms, right? So first we are going, so far what we have seen is we have only so far Char-Pitts method for first order PDE, right? And for Lagrange is also first order PDE. Now we are going to form second order PDE, right? That is, we are going to have the second derivative also. So far we have only have PQ, right? So or P square Q square, that is not a problem. Degree is not a problem. The order is PQ, that is first derivative, dou z by dou x. Now we are going to have a second derivative also. So we are going to define what is meant by second order partial differential equation, and then we are going to classify the we are going to classify the second order partial differential equations, right? So first we are going to define second order partial differential equation, and then we are going to classify the partial differential equation, and then we are going to find the canonical forms, right? Yes. So a second order it's a very easy topic, right? But we can expect, but we cannot expect sure from this topic, right? A second order linear PDE general form is A into uxx plus B into uxy plus C into uyy plus D into ux plus E into uy plus fu equal to G. So this is a general form for a second order PDE, right? Auxx plus Buxy Cuyy Dux plus Euy plus Fu is equal to G, where the coefficient A, B, C, D, E, F, G may be a constant or it can be a functions of x and y, right? Where A, B, C, D, E, F, G may be constants or it can be a function of x comma y. It can be a function of x comma y. For example, we can have x uxx, or it can be xy uxx, or it can be 2uxx. It can be anything, right? Either it can be constant or it can be a function of x and y. So this is the general form for a second order linear PDE, right? Yes. Now we are going to classify this into three types. So when a second order linear PDE will be hyperbolic, right? When it will be parabolic, and when it will be elliptic. A second order PDE can be one of these three types. So first is hyperbolic, parabolic and elliptic. So when this will be hyperbolic, when a second order PDE will be hyperbolic, if b square minus 4ac, or it can also capital B square, right? If b square minus 4ac is greater than 0, then it is hyperbolic, right? When b square minus 4ac, so uxy is the quotient b, right? Here we have b, here we have a, here we have c. So when b square minus 4ac is greater than 0, it is hyperbolic. And when b square minus 4ac is equal to 0, it is parabolic. and b square minus 4ac is less than 0, it is elliptic, right? So I'm going to follow a different methods for finding the canonical form, right? In book you will follow different method, you will have different method, but it is very difficult to follow in book. So I'm using some other methods to find the canonical form. So this will be very easy for you, right? But this method you cannot find in any book. Yes. So first, hyperbolic, parabolic, elliptic, right? So this equation, the second order PDE will be hyperbolic. If this happens, it is this is a parabolic, and this happens if this is a elliptic, right? Yes. Now we are going to find the canonical form for this second order PDE, right? So before getting into that, we know that a second order PDE can be either this form or this form or this form. So first what we are going to do is, first we are going to find canonical form. How to find canonical form for hyperbolic? Second, how to find canonical form for parabolic? Third, how to find canonical form for elliptic? That's how we are going to see now. So first I am going to solve 3 problems here, I am going to solve 2 problems here, I am going to solve 2 problems here, that's it. Because this is not very important, but you can solve any problem in your own if I solve 2 problem alone, right? So first we will study hyperbolic, right? So when hyperbolic, when this happens, b square minus 4ac is greater than 0. So how to find the canonical form for hyperbolic, right? Yes. So it's a very important notes. So first we will study only hyperbolic now, and then we will move on to parabolic and elliptic. You have to only remember the formulas. If you remember the formulas, then it will be very easy for you. So first we are going to study hyperbolic. So hyperbolic is b square minus 4ac is greater than 0, right? B square minus 4ac is greater than 0. Yes, b square minus 4ac is greater than 0. So first step, what you have to do is, so first you find b square minus 4ac. If it is greater than 0, we can fix that it is hyperbolic. Now you need to find the canonical form, right? You need to find the canonical form. So how to find canonical form is, the canonical form is, the canonical form is, right? Canonical form is, I am going to write the formula now for canonical form. A bar u theta theta, right, plus b bar, you just replace x to be equal to theta, y to be eta, right? X to be theta, y to be eta. So u theta theta plus b bar u theta eta plus c bar u eta eta plus d bar u theta plus e bar u eta plus f u is equal to g. Here we don't have bar for f and g. So this is the canonical form for any, either it can be elliptic or it can be hyperbolic, it can be parabolic. The canonical form is this formula, right? Now we have to find a bar, we have to find b bar, we have to find c bar and d bar and e bar, right? So this is our aim, right? So this is a canonical form for all. For parabolic also it is a canonical form, for elliptic also it is a canonical form, for hyperbolic also it is a canonical form, and a bar, b bar, c bar, d bar, e bar will be also same formula for all canonical forms. Now I will define, I will give formulas for a bar, b bar, c bar, all the formulas I will give now. So you have to understand, you have to mug up this very well. So first a bar is a into theta x square plus b into theta x theta y plus c into theta y square, right? A theta x square, b theta x theta y plus c theta y square. Now you just change theta to eta, you will have c bar. So a eta x square plus b eta x eta y plus c eta y square, right? So if you remember a bar, you can write c bar in your own, you just change theta to eta. Now d and e are both are like, so A into theta xx plus B into theta xy plus C into theta yy plus D into theta x plus E into theta y. Now we just change theta to eta here. So we will have A eta xx plus B eta xy plus C eta yy plus eta x d eta x plus E eta y, right. So if you remember these 5 formulas, then you can do any canonical form, right. The only thing is you have to remember A bar, C bar, D bar, E bar. So B bar is quite different. So 2A theta x eta x. Here we are going to have theta and eta in a single term. Here we have either theta or eta, but here we are going to have both theta and eta here. So 2A theta x eta x plus B into theta x eta y plus theta y eta x plus C 2C eta y, sorry, theta y eta y, that's it. So if you remember these 5 formulas, then you can do any canonical form. The only thing is you have to find theta and eta, right. So for hyperbolic we have to find theta and eta in one way, and for parabolic we have to find theta and eta in one way, and for elliptic we have to find theta and eta in another way, that's it, right. So only way that we are going to classify is according to elliptic we have to find theta and eta. According to parabolic, if you know theta and eta we can find all, right, because we already know A, B, C from the given equation. The only thing we don't know is theta x, theta y, eta x, theta y and all that, right. So if we find theta and eta we can find canonical form. So how to find theta and eta for hyperbolic, that is the one first we are going to see, and then how to find theta and eta for parabolic, and how to find theta and eta for elliptic, that is what we are going to see now, right. So remember this formula, the very important formula, just make some colorful notes for these 5 formulas. So and then after finding all this you have to substitute here. This is the canonical form for the given second order PDE, right. So you have to find A bar, B bar, C bar, D bar, E bar, and then you have to substitute here, so that this is the canonical form, right. So we'll move on to, first I will give procedure for finding theta and eta for hyperbolic, right. First we will discuss that and then move on to parabolic and elliptic. So this is the general one, second order PDE, canonical form, and then the 5 formulas. So first we are going to see hyperbolic, how to find theta and eta. Now for hyperbolic, to find theta and eta, So how to find theta and eta for hyperbolic, right. That is what first we are going to see. So first what you have to do is you have to make a formula. The first formula, you have to make use of these 2 formulas. The first is minus theta x by theta y is equal to dy by dx. Okay, we will dy by dx is equal to minus b plus square root of b square minus 4ac divided by 2a. This seems to be a quadratic formula, right. So this is minus of, just write plus, and then another one is minus eta x by eta y is equal to dy by dx is equal to minus of, here you are going to write minus, so minus b minus square root of b square minus 4ac divided by 2a, right. So what you have to do is make use of this formula and this formula, right. So make use of this formula first, and then you find this formula, right. So from here you find C1, right? So here you will have some number or you will have some function. Now integrate this so that you will have one constant here, right? So that here you will have some number or you have some functions, and then we have dy by dx is equal to something. Integrate this, you will have some constant C1, right? So you just bring C1 to one side and bring all the terms to other side and call this to be theta. So our theta is nothing but the value of C1 here. How you will find C1? After finding this, you have to integrate this term. So the integration constant is C1. You keep C1 to one side and bring all the terms to this side, you will find theta. And from here you find C2 and you will have some equation, that is our eta. That is our eta. So after finding theta and eta, you can find canonical form very easily, right? Because you just have to find theta x, theta y, theta xx, theta yy, theta xy from these equations, and from here you have to find eta x, eta y, eta xx, eta xy, eta yy from here, and then you can substitute in canonical formulas to get the canonical form. That's it, right? So you make use of this formula to find C1, make use of this formula to find C2, and rename C1 to theta and rename C2 to eta, and then you find all the derivatives and then you substitute in canonical form, right? So remember this formula, it's a very easy formula, right? But you have to put minus here and plus and minus here, right? Here we have dy by dx, here we have dy by dx. So now we'll move on to the first problem. So the problem, these two equations are called characteristics, right? So these two equations are called characteristic, right? This theta and eta are called the characteristics of this PDE, characteristic of this second order PDE. So in exam they may ask three kinds of question. First one is classify the second order PDE. If they ask us to classify, you have to just say whether it is parabolic or elliptic or hyperbolic. You just have to find b square minus 4ac, and if it is greater than 0, just say it is hyperbolic, less than 0 elliptic, equal to 0 parabolic, the sum is over. If they ask us to find characteristics, you have to find these two, right? You have to find those two. Suppose if they ask us to find canonical form, you find all the derivatives and substitute in the canonical form which I given the formula earlier, right? Yes. So we will move on to the first problem, right? So classify and reduce the equation to canonical form and solve it. The first question is classify and reduce the equation to canonical form. Classify and reduce the equation to canonical form. Right? First question is 3uxx plus 10uxy plus 3uyy equal to 0. So here there is uxy, uy, ux are all 0, right? That is coefficients are all 0. So we have only this equation. So first you have to classify whether it is elliptic, parabolic or hyperbolic. So the coefficient of this is a, and this is our b, and this is our c. D, E, F are 0 here because we don't have the terms. So first you find b square minus 4ac. So b square is 10 square minus 4 into 3 into 3. That is 100 minus 4 is 12, 36. This is 64. So it is greater than 0. So therefore it is hyperbolic. It is hyperbolic. Now what do you need to do? You need to find canonical form. In order to find canonical form, you need to find the characteristics, right? So what is the first characteristic? Dy by dx is equal to minus of minus b plus square root of b square minus 4ac divided by 2a. So our a is 3, b is 10, c is 3 here. So if we substitute here, we will have, this will be minus 10 plus minus 10 plus square root of b square. So 100 minus 64 divided by 2 into 3. So this will be dy by dx is equal to minus. So minus 10 plus, there we will have 36. 4 6 are 12, 36. Here we will have root 64. So root 64 is 8, right? So 8 by 6. So here either we can have ABC to be a constants or it can also be functions, right? So here we have constants. So we have dy by dx is equal to minus of minus 10 plus 8 minus 2 by 6, or dy by dx is equal to 1 by 3, right? So we will keep this, we will keep as it is. Okay, okay. Now what we will do is we will just integrate this, right? Because you have to find C1 from here. So if I cross multiply this, we will have 3 dy is equal to dx. So if I integrate this, we will have 3y is equal to x plus c1, right? 3y is equal to x plus 3c1, or we can also have c1 to be, that means 3y minus x is equal to c1, right? So therefore our theta is 3y minus x, right? Yes. Now we have to find eta, right? For finding eta, we have to just change this to minus, right? So I'll just change it here. You have to make a separate note for this. So for d, I'm making this to be minus, because second formula is minus eta x by eta y, minus, and here we have minus, here we have minus, and this will be minus 10 minus 8, so minus 18. So here we are going to have only 3, right? dy by dx is equal to 3. So this will be dy is equal to 3 dx. So if I integrate this, we will have y is equal to 3x plus c2, right? So therefore c2 is equal to y minus 3x, that is eta is equal to y minus 3x. So these two are the characteristics, right? So far what we have did is we have classified, we have verified that it is a hyperbolic. So I'm just taking a problems that comes out to be hyperbolic, that's why we have hyperbolic here. So for finding characteristic, we have to use these two formulas, that integration constant c1 is theta and the integration constant c2 is eta. Now we need to find the canonical form, right? So what is the canonical form? So I'll just erase it off. So this is the very important part here. So theta is equal to 3y minus x, eta is equal to y minus 3x. After finding theta and eta, then the problem will be very easy for you, because you just have to substitute in the formula, that's it. So our canonical form is, so let's see here, a bar u theta theta plus b bar u theta eta plus c bar u eta eta plus d bar u theta plus e bar u eta plus f u is equal to g. There will be no bar for f and g, and there is no formula for f and g. So before that, what we will do is we will find, so we have theta is equal to 3y minus x, right? Theta is equal to 3y minus x. So you will find all the possible derivative for this. So theta x, theta y, theta xx, theta yy, theta xy. So what will be my theta x? Differentiate this with respect to x. We have minus 1. Theta y will be 3. Theta xx will be 0. Theta yy will be 0, because derivative of minus 1 is 0. Derivative of 3 is 0. Theta xy is also 0, because you have to differentiate this with respect to y. So we have constant here, so it will be 0. Now we have eta. What will be our eta? Eta is y minus 3x. Now you find all the possible derivative. This will be used in substituting in canonical form. So what will be my eta x? It is minus 3. Eta y will be 1. Eta xx will be 0. Eta yy will be 0. Eta xy will also be 0. Right? Yes. Now we need to find a bar, b bar, c bar, d bar, e bar, and then we have to substitute here. That's it, right? So first you will find a bar. So what is a bar? A bar is equal to a into theta x square plus b into theta x theta y, b into theta x theta y, and c into theta y square, right? So this will be a into theta x. What is our theta x? It is -1. So -1 whole square. And what is our a? So from the question we have a to be equal to, from the question we have a is equal to 3, b is equal to 10, c is equal to 3, right? The coefficient of uxx, coefficient of uxy, coefficient of uyy. So we substitute a here, we have 3 plus b into theta x theta y. So theta x is 1, theta y is 3, so -1 into 3, -1 into 3, and the value of b is 10 plus c into theta y whole square. So theta y is 3, so c is also 3, so we have 3 square. So this will be 3 minus 30, 3 minus 30 plus 27, right? 3 square 9, 9 to 3 is 27. This will be 0. So therefore we have a bar to be equal to 0, right? A bar to be equal to 0. Now you have to find b bar. We need to find b bar. So what is our b bar? B bar, the long formula that you have given. So 2a theta x eta x plus b into theta x eta y plus theta y eta x plus 2c into eta y theta y. This is the formula I have given, right? So this will be 2 into our a is 3 and theta x is -1, eta x is -3. So we have -1 -3 plus b. So what's our b? B is 10 theta x eta y. So theta x eta y. So here we have -1 because -1 into 1. Eta y eta x will be 3 into -3. So we have -9 plus 2 into c is 3 and eta y theta y eta y. Theta y eta y is 3 into 1 is 3, right? So c is 3, eta y theta y is 3 again. So this will be 3 to this will be 3, 9, 18, and this will be -1 minus 9 is -10. So -10 plus -10 into +10 is -100. And here we have 2 3s are 6, 6 3s are 18. So here we are going to have -64. Therefore b bar is -64. Now you find c bar, e bar. You need to find c bar. So what's our c bar? A into eta x square plus b into eta x eta y plus c into eta y square. Now this will be a into a is 3, right? A is 3 and eta x is -1. So -1 whole square plus b is 10 eta x eta y. So eta x eta y, sorry, eta x square is -3 whole square. Eta x eta y is -3 plus c is 3 eta y whole square. This will be 1. So this will be -30 plus 27. Again it will be 0, right? So we have found a bar, b bar, c bar. Now we have to find d bar and e bar, right? D bar and e bar. So we know formula for d bar and e bar also. You just have to substitute. So what is our d bar? Our d bar is, so d bar is a into theta xx plus b into theta xy plus c into theta yy plus b into theta x plus e into theta y, right? So this will be 0, this will be 0, this will be 0 because theta xx is 0, theta xy is 0, theta yy is also 0, right? Theta x, d into theta x. So what is our d? Yes, d is 0, e is 0, because in the question we have a, b, c only, we don't have d and e, that is d and e are 0. So therefore 0 into minus 1 and 0 into minus 3. So therefore this whole will fully be 0, and again e bar is also 0, right? So e bar will be a eta xx. So in place of theta we will have eta. So eta x is 0, eta xy is 0, eta yy is 0, and there is no d and e term in the question. So therefore e bar is also 0. So therefore what will be your canonical form? All are 0 except b bar, right? So here we are going to substitute b bar is equal to minus 64 and all are 0. So therefore I can erase this off. So therefore if I substitute b bar is equal to minus 64, so minus 64 u theta eta is the canonical form for this PD, second order PD. That's it, right? So we move on to the next problem. Or else you can also write equal to 0, because G is 0, G is the RHS. So or else you can also write this as u theta eta is equal to 0. This is our canonical form. Clear? So I will do one more problem. So second problem. You can do any problem in your own now on. Now only thing is you have to find theta and eta. If you find theta and eta, then only these are substitution only these are. And you can find theta and eta very easily by using the formula dy by dx is equal to minus half b minus square root of b square minus 4ac by 2a. So second problem is y into uxx plus x plus y into uxy plus x into uyy equal to 0. So first you have to classify whether it is parabolic, elliptic or hyperbolic. So since I am doing only in hyperbolic now, so it will be hyperbolic, right? So again here we have only this is our a and this is our b and this is our c, and again here d, e, f are 0 here. So what will be my b square minus 4ac? So it will be x plus y whole square minus 4 into a into c, right? So if I expand this, we will have x square plus y square plus 2xy minus 4xy. So this will be x square plus y square minus 2xy. So this I can write this as x minus y whole square. So this will always be greater than 0 because we have something square. So therefore it is hyperbolic. Now we need to find the characteristics, right? So first characteristics, dy by dx is equal to minus half minus b plus square root of b square minus 4ac divided by 2a. So this will be dy by dx is equal to minus half. So what will be minus b? And again I am saying don't refer any books, right? If you refer any books, they will follow different methods, and I am following different methods. So minus b. So what will be your minus b? This minus of x plus y, right? B is x plus y plus square root of b square. So x plus y whole square minus 4 into ac. So 4 into y into x divided by 2 into y. So this will be dy by dx is equal to minus half. This will be minus of x plus y plus. So here we are going to have square root of x minus y whole square, right? So we are going to have square root of x minus y whole square, because when you simplify this you will get this here, right? Because it is nothing but b square minus 4ac. So we are taking square root for this, so we have only x minus y here. So here we are going to have 2y. So to simplify this, you will have x square plus y square minus 2yx. I can write that at x minus y whole square. So again this will be dy by dx is equal to minus of minus x plus y, and this will be, and this will get cancelled. So we have x plus y divided by 2y. So this will be dy by dx is equal to minus of, this will be minus x minus y plus x plus y divided by 2y. Minus of x plus y, sorry, x minus y. So this will be x minus y. So this x will get cancelled. So we have dy by dx is equal to minus of minus 2y by y. So therefore this minus will get cancelled. So we have dy by dx is equal to 1. Right? dy by dx is equal to 1, because this term will get cancelled. Minus will get 1. So therefore dy is equal to dx. When I integrate this, you will have y is equal to x plus c1. So therefore what will be our theta? Our theta is y minus x. c1 is our theta. Now we need to find eta. So for finding eta, you just have to change this to minus. So we change this to minus. Here you will have minus. Here you will have minus. Here you are going to have minus. So when I bring minus inside, we will have so this will be minus x minus y, this will be minus x plus y divided by 2y. So minus, sorry, y will get cancelled now. So we have minus of minus 2x divided by 2y. So here we are going to have x by y, dy by dx is equal to x by y, right? So again we need to integrate this. So I can write this as y dy is equal to x dx, or if I integrate this, you will have y square by 2, is it visible? Okay. Y square by 2 is equal to x square by 2 plus some constant c2. So therefore our theta will be y square minus x square, right? I can neglect 2 because 2 is also a constant. So our eta will be y square minus x square. So we have found theta and eta. After that, what you have to do? We have to substitute in canonical form to find the answer. So therefore before that, we will find all the possible derivative, right? Our theta is y minus x. So what will be my theta x is minus 1. Theta y will be 1. Again theta xx is equal to 0. Theta yy is equal to 0. Theta xy equal to 0. So we have eta. Eta is equal to y square minus x square. So our eta x will be minus 2x. Eta y will be 2y. Eta xx, so minus 2, eta yy is 2, eta xy, so what will be my eta xy? So we have to differentiate eta y with respect to x, right? Eta y with respect to x, again it will be 0 because in eta way we don't have x term here. Suppose we have 2yx, we can write 2y here, right? So we need to find canonical form. Before that, what we have to do? We have to find a bar, b bar, c bar, d bar, e bar. So what is our a bar? Our a bar is a into theta x square plus b into theta x theta y plus c into theta y square. Now we substitute all here. So what is our a? So in the question we have a to be equal to y. In the question we have a to be equal to y and b to be equal to x plus y and c to be equal to x. Now we substitute here. What is our A? A is y theta x square. So theta x is minus 1. So minus 1 square plus B. B is x plus y theta x theta y. So theta x theta y is theta x into theta y. So minus 1 into 1. It is minus 1 plus C. C is x and theta y is 1. So 1 square. So this will be y minus x minus y plus x. This will be 0, right? Minus x plus x minus y plus y will get cancelled. So now you find B bar, right? You find B bar. B bar. So what is our B bar? B bar is 2a B bar is 2a. Okay, we will find B bar. Now you find, I will find B bar separately. Now you will find C bar, right? C bar, D bar, both will be 0, right? You can check that. You can check that, right? So you just have to substitute in the formula. That's it. We already found all the terms. We have A, B, C. We have all the terms here. You just substitute in C bar, D bar formula. You will get 0. Now I will find B bar and E bar. So B bar will be, so what is the formula for B bar? B bar is 2a theta x eta x plus B into theta x eta y plus theta y eta x plus 2c into eta y theta y eta y, right? Now we will do this. So this will be 2 into, what is our A? Our A is y theta x eta x. So theta x eta x minus 1 into minus 2x. So it will be plus 2x plus B into, so what? Our B is x plus y theta x eta y. So theta x eta y. So minus 1 minus 1 into 2y is minus 2y plus E theta y eta x. So this will be minus 2x plus 2c. C is x eta y theta y. So eta y theta y will be 1 into 2y, right? And so this will be 4xy, right? 4xy, and here we will have x plus y into minus 2y minus 2x, and here we are going to have 4xy. Now to simplify this, we will have 4xy. So when I simplify this, we are going to have minus 2xy, and we are here minus 2x square, and here minus 2y square, and here minus 2xy plus 4xy, right? Now you can see these 3 will get cancelled because minus 2xy is minus 4xy. So minus 4xy, this 4xy will get cancelled. So what we have left with is, if we take minus common, we will have 2x square minus 4xy plus 2y square, right? I can write like this. If I take minus 2 outside, we will have x square minus 2xy plus y square. So I can write this as minus 2 x minus y whole square. So this is our B bar. So B bar is minus 2 of x minus y whole square. Now we need to find, so we have found A bar, B bar, C bar, D bar. Now we will find E bar, right? We will find E bar. We need to find E bar because in E bar we have eta xx, eta yy. So we will find E bar now. So E bar. So what is formula for E bar? A into eta xx plus B into eta x, eta y, eta xy plus C into eta yy plus d into eta x plus e into eta y. So this will be 0, this will be 0 because we don't have d and e in the question. So what we have is, what is our a? Again eta xy will also 0. So we only have this term and this term. So what is a? A is y, right? A is y. Eta xx is minus 2 plus c is x, eta yy is 2. So we have minus 2y plus 2x, or we will write this as 2 of x minus y. That's it. So we have found all the formulas. Now we will substitute in the canonical form. So we substitute canonical form. So we have only b bar and e bar are non-zero. So we substitute here, we will have minus 2x minus y whole square u theta eta plus 2 into x minus y u eta is equal to 0. This is the canonical form. Because a bar is 0, b, we have b into u, b bar u theta eta. So b bar is minus 2 x minus y whole square, and again c bar d bar both are 0, all are 0. So you only have e bar u eta. So e bar is 2x minus y. So this is our canonical form. Suppose if they asked us to solve the canonical form, so we have found the canonical form. Suppose if they asked us to solve this canonical form, they won't ask. Suppose just for extra information, suppose if in exam if they say us to find the canonical form and solve the canonical form. Suppose if you want to solve this equation, you can also solve this equation by. So I will solve this equation now. So we have found the canonical form to be minus 2 into x minus y whole square u theta eta plus 2 into x minus y u eta is equal to 0. Suppose if they ask us to solve the canonical form, what you have to do? That's what we are going to do now, right? So I can take minus 2x minus y outside. If I take minus 2x minus y outside, we will have x minus y u theta eta plus u eta is equal to 0. This is not equal to 0. That means x minus y u theta eta plus u eta is equal to 0. We need to solve this equation, right? So we know that what is our theta? Our theta is y minus x, right? You already found the characteristics. Theta is y minus x, and the eta is, you have found, right, y square minus x square. So I can replace this to be minus theta, right? Minus theta, because theta is y minus x. So this is minus theta u theta eta plus u eta is equal to 0, right? Yes. Now I can write this term to be if I take minus common, here you will have plus. I can also write, I can also take minus outside and I can equal that to 0. So we will have theta u theta eta plus u eta is equal to 0, right? Now I can write this term to be dou by dou theta of theta u eta, right? I can write this because when you fix theta and if you differentiate with respect to eta, you will have u theta eta. And if I fix u eta and if I differentiate this with theta, we will have 1. So I can write this term to be this. So integrating this will give you a solution. That's it. Suppose in the exam if it asks us to find or solve that canonical form also, you have to change x minus y in terms of theta and eta, and then you have to integrate it. So if I integrate this, we will have, so you can see this is equal to, if I differentiate this term, it will be equal to 0. So if we integrate this, we will have this term theta u eta is equal to some function of eta, because this is nothing but a constant, right? When you are differentiating this with respect to theta, you are getting 0. That means this has to be function of eta, then only you will have differentiation of this is 0, right. Constant term also comes under this. If you are, suppose if I have theta square, if I differentiate with respect to, sorry, eta square, if I differentiate this with respect to theta, this will be 0. So if you are getting 0, then this has to be a function of eta. So therefore theta, see, you need to find u, right. Our aim is to find u. Our aim is to find u. So therefore u eta is equal to 1 by theta f of eta. Now if I need to find u, that means I need to integrate this with respect to eta, right. I need to integrate with respect to eta. So therefore u is equal to 1 by theta integral f of eta d eta, that's it, right. F of eta d eta plus some constant, right, plus some constant g of theta, that's it. This is our solution, this is our general solution. Now you can also replace eta to be y square minus x square and theta to be x square minus y square. Therefore this is our, suppose if they ask us to solve the canonical form, that means you need to find the value of u. So for finding the values of u, so you just change x minus all the xy to theta eta, and then you need to find the value of u, that's it, right. So we move on to third problem. Third problem you are only going to do, I am just going to only give you the answers. I'll just find the characteristics. Now you need to find the I will give you one problem for practice now. I think two are watching. So you find the characteristic for this problem. The third problem is uxx minus 2 sin x uxy minus cos square x uyy minus cos x uy equal to 0. You need to find the canonical form for this. I think two are watching. If you want to try, you just text, or else I will do, right. Just find the canonical form for this. You can just take 2 minutes or 3 minutes to find the canonical. First you find characteristic for this, right. I think two are watching. Okay. uxx minus 2 sin x uxy minus cos square x uyy minus cos x uy. The only thing that will change for elliptic, parabolic, hyperbolic is for finding theta and eta only we will have different methods. After finding theta and eta, all are alike. We have to differentiate theta x, theta y, theta xx, theta yy, eta x, theta y, eta xx, theta yy, eta xy, and then you will substitute in canonical form formula. The only thing is for finding theta and eta we will have different classifications. So for hyperbolic you have to use two formulas, that is dy by dx is equal to minus of that formula, and for parabolic I am going to give another formula, that's it. Yes, try. Cos square x uyy minus cos x uyy. Surely it will be hyperbolic. Surely it will be hyperbolic. So we just find the two characteristics. The question is visible. The question is uxx minus 2 sin x uxy minus cos square x uyy minus cos x uy is equal to 0. So the characteristics are, so you can verify that it is hyperbolic, right? So you will have when you simplify this, you will have 4 sine square x plus 4 cos square x. Yes, exactly. The first characteristics is x plus y minus cos x. X plus y, you just check whether it is plus cos x or minus cos x. X plus y minus cos x, the first characteristics. So dy by dx is equal to minus half minus b plus square root of b square minus 4ac divided by 2a. So this will be minus half minus b. So our a is 1, b is minus 2 sin x is b, and c is minus cos square x, and uy is, I think it is e. Yes, e is equal to minus cos x. E is equal to minus cos x. So by substitute here, you will have, so minus b, so this will be plus 2 sin x plus square root of b square. So b square will be 4 sin square x, 4ac, 4a is 1, c is minus cos x. So we will have, c is minus cos square x, so we will have plus 4 cos square x divided by 2 into 1. So this we will have 2 sin x plus, so here we will have only 2, right? Because if I take 4 common here, we will have sin square x plus cos square x, which is equal to 1. So if I take root of 4, it will be 2 divided by 2. So if I bring all the terms, if I take 2 outside, if I cancel, we will have minus sin x minus 1. So that means dy is equal to minus sin dx minus dx. So by integrate this, we will have y is equal to minus the differentiation of integration of sin x is minus cos x. This will be x. So we have plus some constant c1. So therefore y is equal to cos x minus x plus c1. So therefore theta, if I bring x to this side, we will have x plus y minus cos x. This is our first characteristic, x plus y minus cos x. And the second characteristic will be, here we will have minus, here we will have minus. So here we are going to have plus, right? You are going to have plus, you are going to have plus, you are going to have plus, you are going to have plus. Therefore second characteristic eta will be y minus x minus cos x. This is our second characteristic eta. Now you will find theta x. Theta x will be 1 minus 1 plus sin x, right? Cos x is minus sin x. Theta y will be 1. So you find theta x, theta y by theta xy, and from here you will find eta x, eta y, eta x, eta y. I'll just tell you the answer, right? I'll just tell you the answer. So you will have a bar to be equal to 0, and you will have b bar to be minus 4. You will have b bar to be minus 4. You will have c bar to be equal to 0. You will have d bar to be equal to 0, e bar to be equal to 0. So you will have b bar to be minus 4. So therefore canonical form will be, so we have only coefficient for b bar. So canonical form is minus 4 u theta eta is equal to 0. Suppose if you need to solve this, u theta eta is equal to 0, that means what will be my u? U is a function of f of theta plus f of eta, or it can be some g of eta. This is a solution. Suppose if you need to solve this, so if we have u theta eta to be equal to 0, that has to be a function of theta and eta, then only we will have u theta eta to be equal to 0, right? That's it. Now we will move on to parabolic, right? So from parabolic elliptic we can finish this in 2 minutes if you understand hyperbolic. So we move on to parabolic. So parabolic means b square minus 4ac has to be equal to 0. So this is the answer, right? You will get b bar to be minus 4 and all the terms to be equal to 0, and here canonical form will be minus 4 u theta eta is equal to 0. If you want to solve, u has to be a function of theta and eta, f of theta plus g of eta, and then you can also substitute theta to be equal to x plus y minus cos x, eta to be equal to x plus y, y minus x minus cos x. That's it. So we will finish this topic today, and then each equation, Laplace equation. That's it. So parabolic. So parabolic. So this will be when b square minus 4ac is equal to 0, then the second order PD is parabolic. Listen very carefully. If you listen this for 30 seconds, you can do all the problems in parabolic, right? So all are same, all the formulas are same. The only thing that will change is in finding theta and eta, right? So I'll just let you know the formula for theta and eta. So our theta is theta. In order to find theta, there we have used two formula, dy by dx is equal to minus half b minus on that formula. Now we are going to use the first formula, that is minus theta x by theta y is equal to dy by dx is equal to b by 2a, b by 2a, that's it, right? So since here b square minus 4ac will be 0, so we will use this formula to find the first characteristics. When you integrate this, you will have c1, but you need to find another characteristic also, right? But you cannot find another characteristic here. There you can find, because we have plus into some number, minus into some number, but here since this number is 0, because we have b square minus 4ac equal to be 0, we can find only one characteristic from this. Now in order to find another characteristics, very carefully, listen very carefully, you can choose eta to be anything. You can choose eta to be anything, right? You can choose eta to be anything. Eta can be chosen in a way such that the Jacobian is not 0, right? So I'll always recommend you to choose eta to be equal to y, right? You can choose any eta. Here it is just that convenient. This was formulas, right? So actually this is equal to this, this is equal to this, right? That's why we will integrate this. If I integrate this, we will get c1, meaning that if I integrate this, we will have theta and theta y, right? So you just remember this enough, right? So here we are integrating to find c1, meaning that if I integrate this, we will have theta, right? Theta. That's what we are doing there. So don't worry about this term. Now you have to choose eta such that you can choose any eta such that our Jacobian should not be 0. Jacobian should not be equal to 0. That means theta x, theta y, eta x, eta y should not be equal to 0. You can choose any eta. You can choose eta to be xy, x square, xy. You can choose any eta such that this has to be non-zero. Right? You cannot choose eta such that this turns out to be equal to 0. So here you will find theta. Right? From this you can find theta x, theta y. Here eta x, eta y. But you will always choose eta to be equal to y. 99% this will work out. Right? Just for the convenience, just for the equality, we will only choose eta to be equal to y. Maximum if you choose eta is equal to y, then this will be 1, this will be 0. Right? So therefore our theta y should never be 0. If you are, we will always have y here. So therefore this determinant should always be non-zero. That's why we are choosing eta to be equal to y. For the most of the problem, this eta will work out. Right? Yes. Now you just need to find theta, and you just close your eyes and you write theta to be equal to y. Now you will find theta xx, theta y, theta xx, and from here you will find theta x, theta y, theta xy, and then you substitute in canonical form. That's it. Right? Now I think you can do any problem in your own. Right? So for theta, substitute here and find C1. And for eta, just close your eyes and just write eta to be equal to y. Right? Make sure that this Jacobian is not 0 after substituting eta to be equal to y. So we'll move on. The first problem. First problem is, I'm just going to give you hint. That's it. You can do any problem. X square uxx minus 2xy uxy plus y square uyy equal to e power x. Remember, we have g here. In previous sum we have g to be equal to 0, but here we have g as e power x. Now what will be my b square minus 4ac? So b square is minus 2xy whole square, and a is x square and c is y square. So we have 4x square y square minus 4x square y square. It is 0. That means it is parabolic. So for parabolic, these are the two characteristics. So first we need to find dy by dx is equal to b by 2a. So what is our b here? Our b is minus 2xy and our a is x square. So we cancel x and x. We have dy by dx. dy by dx is equal to minus 2y by x. Right? Minus 2y by 2x square. Right? So these two will get also cancelled. So minus y by x. So this you can integrate this, right? So integral dy by y minus integral dx by x. So I'm writing y dx. So this is log y is equal to minus log x plus log c1. So this I can bring log x to this side. So we bring log x to this side, we will have log x plus log y. So log x plus log y is log xy is equal to log c1. Therefore c1 is equal to xy. That means theta is equal to xy. Theta is equal to xy. Now we can just write eta to be equal to y. Y, if I choose theta is equal to y, what will be my Jacobian? Theta x, theta y, eta x, eta y. So what is our theta x? Y. Theta y is x. Eta x is 0, eta y is 1. You can see this is equal to y. Therefore this is not equal to 0. So you can choose eta to be equal to y. You can choose any eta. It is not that you have to choose y, right? Yes. So we have found two characteristics to be theta to be xy, eta to be y. Now we can do right? So same procedure. Theta x, theta y, theta xx, theta x. And from here eta x, eta xx, eta y, eta xy. You find a bar, b bar, c bar, d bar, e bar. If you do that, you will have a bar to be c bar, a bar, I'll just write the answer, a bar to be equal to 0, b bar to be equal to 0, c bar to be equal to y square, d bar is equal to minus 2xy, and e bar to be equal to 0. Right? So you substitute in canonical form. Remember, in canonical form you don't have bar for F and U, we don't have bar. So if I substitute in canonical form, we have, so what is our canonical form? A into A bar U theta theta plus B bar U theta eta plus C bar U eta eta plus D bar U theta plus E bar U eta plus Fu is equal to G. So we don't have bar for F and G, but here F is already equal to 0, but we have G to be equal to e power x, we don't have F here. So if we substitute here, we will get the answer to be equal to y square C bar U eta eta minus 2xy d bar. So U theta is equal to e power x. This is the canonical form. So one more problem in parabolic. I'll just find you the characteristics, then you can do any problem from now on. If you find theta and eta, then it is very easy for you. So second problem in parabolic, sine square uxx plus sine 2x uxy plus cos square x uyy equal to x. Now verify that it is parabolic, right? It will be parabolic. Now what you have to do is, we will find characteristics, right? So first characteristic is dy by dx is equal to b by 2a. So what is our b? It is sine 2x. 2 into a is sine square x. So sine 2x divided by sine square x. So I can write sine 2x as 2 sine x cos x divided by 2 sine square x. So this I can cancel, this I can cancel. So we have cos x by sine x, which is cot x. So we know internal cot x is log sin x. So we have dy by dx is equal to cot x. So that means dy is equal to cot x dx. So that means y is equal to log sin x plus c1. Therefore our theta is y minus log sin x. This is our theta. Now you can choose eta to be equal to y. Eta is y, right? Now you can find it from now on, right? You can find from now on. You just have to find a bar, b bar, c bar, d bar, e bar, and just write the answer for that. So we have a bar to be equal to 0, b bar to be equal to 0, a bar, b bar 0, c bar is cos square x, d bar is 1, e bar is 0, right? E bar is 0. Now you substitute in canonical form. Remember we have g here, we have g to be x here. So canonical form we will have, for f and g we don't have bar. So therefore fu plus g will always be there, but since f is 0 here, because we don't have f term, f is 0 here, so we have this canonical form is equal to x, right? This substitute cos square x, c bar is equal to cos square x, d bar is equal to 1 in canonical form, you will get the answer. The answer is cos square u eta eta, cos square. So we have for c we have cos square x, so cos square x u eta eta plus d bar we have 1, so d bar is u theta is equal to x. This is our canonical form, cos square x u eta eta plus now we will go for elliptic, right? So far we have finished hyperbolic, parabolic. Now we'll go for elliptic, right? Now for elliptic, we have to introduce a transformation. So both elliptic and hyperbolic are more or less same. So what we have to do is, so again I am just going to give you only the hint. I will send photo for, I will do one problem for you to work out. Now elliptic. So b square minus 4ac will be less than 0, right? So what, suppose if it is hyperbolic, what we will do? We will find theta, we will find eta, right? Same formula. That is, we will use the same formula. dy by dx is equal to minus b plus square root of b square minus 4ac divided by 2a, and dy by dx is equal to minus b plus square root of b square minus 4ac divided by 2a. Now from here you will find theta, from here you will find eta. Up to this you have to do like as it is. If it is elliptic, you can proceed theta x, theta y, and then you can substitute canonical form. If it is hyperbolic, you can find theta x, theta y, theta xx, theta yy, and substitute in a bar, b bar, c bar to find canonical form. Suppose if it is elliptic, what you have to do is, you have to introduce another transformation. That is, what transformation you have to make is, you have to choose you have to find alpha and beta. You are changing theta to be in terms of alpha and eta to be in terms of beta. So for alpha, what you have to do is, you have to find theta plus eta by 2, and here, and for beta, theta plus eta by 2, theta minus eta by 2, right? So, and then the canonical form will now be fully changed in terms of alpha and beta. So what will be canonical form? A bar u alpha. So in place of theta, alpha, plus b bar u alpha beta, plus c bar u beta, right? U beta. I'm just changing alpha, theta to be alpha, eta to be beta, plus d bar u alpha, plus e bar u beta, plus fu is equal to g. This is our canonical form, and all the formulas a bar, b bar, c bar, d bar, e bar will be changed to alpha and beta. For example, what is our a bar formula? A into theta x square, right? Theta x square. That means you have to change this to alpha x square, plus b into theta x theta y, alpha x alpha y, plus c into theta y square, alpha y square. You have to change theta to be alpha, eta to be beta. You can proceed all the formulas now on, right? You just change theta to be alpha, you just change theta to be alpha and change eta to be beta in all the formulas. You will get the canonical form. That's it. You have to make only one transformation, alpha to be theta plus eta by 2, beta to be eta minus theta by 2. So we will work out one problem and then wind up this video, right? So remember this transformation, alpha and beta, and then same. The only thing is, we are changing to in terms of theta to alpha beta. So last problem, uxx plus x square uyy equal to 0. This x is not equal to 0. So first we will classify this as elliptic or hyperbolic. So we have a to be equal to 1, b to be equal to 0, c to be equal to x square, and d, e, f, g all are 0. All are 0. So what will be my b square minus 4ac? So 0 square minus 4 into x square, it will be 4x square. Always it will be less than 0 because we have x square. This will be positive, so here we are negative, it will always be less than 0, so it is elliptic. So first you have to find alpha and beta, you have to find theta and eta similar way as we did in elliptic. So first we will find dy by dx is equal to minus of minus b plus square root of b square minus 4ac divided by 2a, right, minus of minus b plus minus of minus b. I think the same formula here also. Yes, minus b is. Now we will substitute here. So we will have minus of our b is 0 plus square root of b is 0 and a is 1, c is x square divided by 2 into 1. So here we will have minus square root of minus 4x square divided by 2. So I can write this as I, right? So in elliptic we will always have I term because b square minus 4 is less than 0. So I can write this term as minus of square root of 4i square x square divided by 2. This will be minus 2xi by 2. So this will be cancelled. So we have minus xi, right? Minus xi, right? Yes, minus xi. So therefore we have dy by dx is equal to minus xi. So we have dy is equal to minus xi dx. So we integrate this, we will have y, minus I is constant. So x square by 2 plus c1. So therefore what will be our theta? Our theta is x square by 2 minus, okay, we can make anything. Okay, we can also write this term to be all are same. We can also write this term to be dy by minus I is equal to x dx, and if I integrate this, minus 1 by I y is equal to x square by 2 plus c1. So for removing I, what I can do is I can multiply I and I here. So this will be I square will be minus 1. So here we have minus I by minus 1. So we have plus iy is equal to x square by 2 plus c1. So therefore c1 will be x square by 2 minus iy, that is theta is equal to x square by 2 minus iy. Now you have to find eta, right? So we write here. So theta is x square by 2 minus iy. So what will be my eta? So our eta will be plus, will be minus. So here we have minus, and here we have minus, here we have minus, here we have minus. So this will be plus xy. So when it is plus xy, we will have plus xi. So there will be no minus, there will be no minus, and again there will be no minus. So here we are going to have minus iy. So here we are going to have plus iy. So our eta will be x square by 2 plus iy. If it is elliptic, if it is hyperbolic, you can find canonical from here itself, a bar, b bar, c bar, d bar, by differentiating theta xx, theta yy. But now this is elliptic, right? So since it is elliptic, we have to change in terms of alpha and beta. Now what will be my, so we have to change in terms of alpha and beta. So alpha is theta plus eta by 2, right? So what will be my theta plus eta? So if I add this, these two will get cancelled, right? So we have 2x square by 2, 2x square by 2 by 2. So we have x square by 2, right? We have x square by 2, right? Just have to add and divide. If I add this, this will get cancelled. So when I add this, we will have 2x square by 2. So 2x square by 2, this 2 will get cancelled. So we have x square by 2. Now what is our beta? Beta is theta minus eta by 2. So if I subtract this, this 2 will get cancelled. Here we have minus 2iy, minus 2iy by 2. So here we are going to have minus iy. Sorry. Just make one change. Beta is theta minus theta by 2i. Please change formula. So alpha is theta plus eta by 2 and beta is theta minus eta by 2i. Please make small correction, 2i, right? 2i. So I will get cancelled. So we have minus y, minus y plus y. Yes, theta plus eta by 2, theta minus eta by 2i. So when I subtract this, we will have minus 2iy divided by 2i. Yes, minus y. So this is our alpha. So our alpha is x square by 2 and our beta is minus y. So from now you can from now on you can do this very easily, right? So you have to find alpha x. Alpha x is 2x by 2, that is x. Alpha xx 1, alpha xy 0, alpha y 0, beta x 0, beta y minus 1, beta xx 0, beta yy is 0, beta xy is 0. Now you find a bar, b bar, c bar, d bar, e bar. Substitute in the formula, you will get the canonical form, right? Yes, this is our, you can do this, right? If you have any doubt, you can ask. If you want me to do, I can also do. It's very easy. So we have alpha, beta. So canonical form will be a bar u alpha alpha plus b bar u alpha beta plus c bar u beta beta plus e bar u alpha plus b f bar u beta plus fu is equal to g. Now what will be my a bar? A bar is u alpha alpha, sorry, a into u alpha alpha. U alpha, sorry. Our a, what is our a bar? A bar is a into alpha xx, right? Alpha xx plus b into alpha xy, alpha x, what is our a bar formula? Alpha x square, right? Yes, alpha x square, alpha x, alpha y square. So alpha x is 2x by 2, so that is x. So we have a into x square plus b into alpha x, alpha y, alpha x, alpha y. So our alpha x is 2x by 2. So we have x, alpha y is 0, and here we will have alpha y whole square. So we will have only a x square. What is our a? A is 1 here, right? A is 1. So we have a bar to be equal to x square. Now in similar way you will find b bar, c bar, d bar. You will have c bar also equal to x square and all the terms are all 0, right? So b bar will be 0, e bar will be 0, f bar will be 0. So canonical form will be x square u alpha alpha, x square u alpha alpha plus x square u beta beta is equal to 0. This is our canonical form. Plus u alpha, you have f to be equal to 1, I think. Yes, we will have d bar to be equal to 1. So we will have a bar to be x square, c bar to be x square, d bar to be equal to 1. So we will have plus u alpha equal to 0. This is our canonical form. X square u alpha alpha plus x square u beta beta plus u alpha is equal to 0, right? Yes. So therefore that's it. You just practice some more problems also. You can do any problem. Only thing is you have to find theta and eta. That's it. You have to substitute in formula, right? So tomorrow what you are going to see is we are going to see ET equations, Laplace equation problem over. So maximum ET equation 2 classes or 1 class, 2 classes, Laplace equation 1 or more. So in 3 classes you will finish partial differential equations. So this is 11th class, I think. So in 15 classes you will 15 class itself we will finish partial differential equation. I thought it will be around 20 classes, but we will finish this in 15 classes itself, 15 or 16, right? So that's it. If you have any doubt you can ask. Only 2 are watching. Why we wrote theta x by theta y before, that's what I have said. Please also tell the format to write in exam. So in the exam what they will give is reduce the equation to canonical form, classify and reduce the equation. So first you just classify that whether it is elliptic or hyperbolic or parabolic. You would find b square minus. So first step is, so step 1 is from the question you write down a, b, c value, d value, e value, f value, g value, all the value you will write, and then you find b square minus 4ac, b square minus 4ac, and to check whether it is less than 0 or greater than 0 or equal to 0. So depending upon that you have to find theta and eta. So you just check whether it is equal to find characteristic theta and eta. So in order to find theta and eta, so if it is hyperbolic, you find 1 dy by dx is equal to the first formula, you find theta from here. 2 dy by dx is equal to second formula, you find eta here. Step 3, we know that the canonical form, you write the formula for canonical form, that is a bar u theta theta plus b bar u theta eta plus c bar u eta eta plus something equal to g, fu plus g equal to 0. Now you find a bar, b bar, c bar, d bar using that formula and substitute here. So we have 3 steps. Coming back to next question. Tell the format I have done. Number of questions to be done from canonical. Actually this topic is very rare, right? Very rare. I think if you look at the books, they will follow different methods, right? So you just, what you do is you just take PYQ. I think there are 4 to 5 questions in PYQ. Just solve that only. That is enough, right? So this question plus PYQ question. You collect all the question and you solve that. If you have any doubt, we will discuss that. And number of questions. Then why f is 0? Where is f here? What is, why f is 0? What is our general form of second degree equation? So general form is a u xx plus b u xy plus c u yy. I think it is not visible if I write there. So what is our general form? A u xx plus b u xy plus c u yy plus d u x plus e u y plus f u is equal to 0. So in the question we don't have this term, that is we don't have, in the question we don't have 2u or xu. If we have this, you will choose f to be equal to x, but in the given question we have f to be equal to 0 because we don't have this term in the question. So therefore that means f are the coefficients, right? So if we don't have that term, that means coefficient is 0. So in the question we don't have u term, right? So we have f to be equal to 0 here. So I think that I have cleared. And why f is 0 is done. Sir, in parabola how we will tell why we took eta, right? It is not meta, it is eta. So eta, so just choose, you just say, so after finding theta, you just find eta to be equal to y, you just write that since the Jacobian is non-zero, that's it. You just write this line, choose eta to be equal to y such that Jacobian is non-zero, right? You can also do that. So we have to choose eta such that the Jacobian is non-zero, right? And it is not that you have to choose eta to be equal to y, you can choose any eta. And sorry, okay, that's it, right? Please send the problems. So just take a P by Q. I don't have any problem because I have solved all the problems in this book, right? In this book I have solved all the problems. Now we have to take P by Q, right? So you have P by Q, right? So the material. So you just find the question canonical form. So I think 2016 also they have asked one question, I think. So you just collect that question and practice. So if you have any doubt, let me know. Right? I have one question from Elliptic. I'll just give you the question, you can practice it, right? So I'll give you one question from Elliptic, but it's a very big question. So the problem is, and also the integration bit is quite difficult also. So the question is, the question is 1 plus x square or 1 plus y whole square. Okay, 1 plus x whole square uxx 1 plus y whole square uyy plus x into ux plus y into uy is equal to 0. So I'll send the solution. I will return the solution. I'll just give you the I'll send a photography for this. So here we have theta to be log of x plus square root of x square plus 1 plus I into minus I into log of y plus square root of y square plus 1. This is our theta, and eta to be, here we have plus I. And then you find alpha plus beta, alpha minus beta. So you have alpha to be log of x plus square root of x square plus 1, and you will have beta to be log of y plus square root of y square plus 1, right? If you want solution, you can send detailed solution after the class, right? So that's it. So we're going to finish PDE. We are in the last stage, right? So we'll see next class. Goodbye. Thank you. I think if any doubts, no problem. Is there any doubt? Okay, right? You just try this problem, right? So that's it, right? So tomorrow, in the next class, we will see equations, right? Yes, no problem. Yes. Thank you.